Welcome to Module 5 of the online tool for designing ventilation systems to reduce manure pit entry risk workshop. And this session is a participant project. You know, we've just spent 4 modules in which we gave you an overview and we've led the parade. We have inputted all of the data. We've gone to the right portions of the online tool, and we've showed you how. Now it's the time for you to reinforce what you learned, and maybe also to identify those portions of the presentation that maybe you didn't catch all of it quite correctly. So what we're going to do is, in this session, is just introduce a project for you to input, generate your results, review your results, interpret your results, and compare the results you got to the results we got for the same case study. So our goal is for you to, after I get finished presenting, to access the online design tool yourself, to name the project that you're going to input, to generate the input file for a defined tunnel ventilated barn above a slotted covered manure pit, for you to preview that input before you submit it, and then submit that project for solving. The case study that we're going to use, that I want you to use, is a familiar one. It's one that you've done before, so if you get stuck, we did this intentionally, because if while you're independently inputting this information, you get stuck, you can go back to module number 3, workshop PDF files that you downloaded, and you can see whether or not what you have inputted is the same as what we inputted. Now, how much you choose that as a cheat sheet and how much you just use that as a check sheet is up to you, but I would argue that the best way for you to do this is to use it as a check sheet rather than as a cheat sheet, if you will. So I would encourage you to try to input this problem file independently, and after you do that, then go back and compare your inputs to the Module 3 data inputs that I presented in Module 3. The barn that you have is a 40 by 100 by 10 foot tunnel ventilated barn. We're going to use parallel flow, if you remember what that means. It's going to be for a swine finishing barn for 450 pigs. Barn ventilation rates 55,000. The manure pit is full size, 40 by 100 by 8 feet underneath the barn. Totally slotted floor. Manure pit ventilation rates 9,500 CFM. The pit fan is located in the pit floor at the longitudinal center line and offset 3 feet from the barn ventilation air intake. So it's at the right hand end. That ventilation air is going to be directed downwards, perpendicular to the slotted covered floor. Use recirculated air from the barn. Initial gas concentrations, 120 for hydrogen sulfide, 85,000 for methane, 70,000 for carbon dioxide, and 300 parts per million for ammonia. This just defines the case again. Just remember, we have our barn fans at the left end. We have our pit ventilation fan that's depicted in yellow at the right end. Parallel flow. Looking at it again, this is the case you're modeling. Total ventilated barn, the full-size manure pit, fully slotted floor, pit fan at the right-hand end, at the end opposite the barn exhaust fans, which are in the opposite end wall. Barn and pit airflow both directed from right to left. So at the conclusion of this workshop presentation, which is very short, here's what I'd like you to do. Access the ventilation design tool at the website shown. Input the data to characterize this tunnel ventilated example. And as you input this, I would recommend very highly that you take the PDF file of this PowerPoint presentation and go to that page where we define all of the barn characteristics and the ventilation characteristics, and have that aside of you so that you don't have to do that from memory. Then, when you have the inputs in, preview the project input using the preview feature. In other words, look at the 3D file that you generated. Also, conduct a check constraints exercise. Both of these will help you identify input errors and get those corrected before you save the project. Then save the project, submit it for solution, wait until you get it. Might be 30 minutes, it might be a couple hours. Once you get that back, then access and review those simulation results. And then compare them to the results for Module 3 that were provided in the supplemental results file on the Vent Design website. So what you need to do is get onto this website, log in, give us your user ID and your password, do those steps, compare your results to our results. Once you have that done, if you're really interested, access the saved input file and modify some of the inputs. Change the location of the fan to the barn exhaust end to make counterflow. Change the initial hydrogen sulfide concentration to 100 parts per million, and then resubmit it for solving. What this would do is shows you how easy it is to change different parameters and give you an opportunity to compare outcomes for two different situations. All I can say is I encourage you strongly to do this. I think it'll be very, very, very helpful. And I hope you enjoy the modeling, and I hope you enjoy the simulation experience. It really can be quite interesting. With that, we'll conclude module number 5. And when you have completed your modeling exercise, and I look forward to seeing you for module number 6, in which we will do a case study for a naturally ventilated barn located above a slotted covered manure pit. Thanks for joining us, and have a good day.